Namaskar. My name is Dr. Sarita Choudhary. Today I am going to deliver a lecture on cement. It's very important and valuable topic in engineering chemistry as well as civil engineering students. Overview of my presentation, which includes introduction of cement, type of cement, raw material used for making cement and consequence of cement, setting of cement, hardening of cement. Start with the introduction of cement. Cement is fine grey powder which has adhering property and on mixing with water it forms a paste which can bind building material like stone, bricks, gravels. In simple words, it's a fevicol for binding construction material. The cement generally we are using are of two types, hydraulic cement and non-hydraulic cement. Hydraulic cement, this sets and harden because of hydration and hydrolysis reaction between the anhydrous cement powder and water, and this is capable of sweating and hardening underwater. Non-hydraulic cement, these are materials which harden in air and can't be used underwater because it hardened due to carbonation reaction by carbon dioxide present naturally in the air. The classification of cement. In classification of cement, we find four types of cement based on their chemical composition: natural cement, pozzolana cement, slag cement, and Portland cement. Natural cement produced by calcining and pulverizing natural cement rocks consisting of clay and limestone, but this is very weak type of cement. It's cheaper but do not impart sufficient strength. Next is pozzolana cement. It is produced by mixing lime with volcanic ash from Pozzolana, Italy. It has hydraulic property and it can be used on mixing with Portland cement. Third is slag cement. It's prepared from the blast furnace slag and hydrated lime on pulverization. It sets slowly and has lower strength. The fourth one is Portland cement. It is discovered by Joseph Escudin scientist in 1824. It consists of lime, silica, alumina and iron, most valuable and used for construction work. This is hydraulic cement. Cement has property of setting and hardening in presence of water, so it is called hydraulic as we discussed earlier. So the essential constituents of cement used for construction purpose are compounds of calcium, that is calcareous material, and aluminum and silicon, that known as argillaceous material. Some constituents which are using in making cement are calcium oxide or lime calcium oxide. It is used 60 to 70%. It is principal constituents of cement and responsible for hardening. Silica SiO2 we are taking in 70 to 25% by mass and it imparts strength in cement. Alumina Al2O3 5 to 7.5%. Its function in cement, it makes cement quick setting and it excess weakens the cement. Next is pure oxide, magnesia MgO, magnesium oxide 2 to 3%, ferric oxide 1 to 2.5%, sulfur trioxide 1 to 1.5%, other oxide 1%. These all oxide give cement to the soundness. Soundness means if we are mixing water in cement, the volume not so much be increased. If a volume increased in a very extent, that cement is known as less sound cement. Less sound cement. If volume is not appreciably increased, then the cement is sound cement. So these four Raw materials are used in making of cement: calcium oxide, silica, alumina, and few oxides. Apart from these, after formation of concrete, we are adding gypsum in cement by 2% by weight. And the role of gypsum in cement, it delays the setting time of cement. Next is setting and hardening of cement. Cement, when mixed with water, forms a plastic mass. During hydration reaction, gel and crystalline products are formed. Stiffening of original plastic mass when cement is mixed with water is called setting, and developing strength in it is called hardening. Setting is due to formation of gel which adheres to stones, sand, tiles, etc., whereas hardening is due to formation of crystalline product on hydration. The process of solidification comprises of setting and hardening. The process of setting and hardening of cement is partially a chemical change. Why it is chemical? Because it involves hydrolysis of various constituents with accompanying heat changes. And partially it is physical also. Why physical change? Because in setting and hardening there is a formation of gel and separation of crystalline products for hardening. So both processes are partially chemical and partially physical. In the hydration of cement means when we are adding water in cement, two type of reactions takes place: hydrolysis and hydration. Before discussing hydration and hydrolysis, first of all, we should know about the constituents of cement. There are four main constituents of cement which form during the formation of cement: C2S, C3S, C3A, C4AF. Again I am repeating, four constituents of cement: C2S, C3S, C3A, C4AF. C2S stands for dicalcium silicate, di-calcium silicate. C means calcium, calcium oxide. And C3S tricalcium silicate, C3A tricalcium aluminate, C4AF tetracalcium aluminate. How they are formed? In what proportion they are formed? Two calcium oxides when mixed is react with one silica, then formation of two calcium oxide dot SiO2, that is known as dicalcium silicate. And similarly C3S, when we are taking three calcium oxide molecule with one silica, there is formation of C3S, thrice calcium oxide dot SiO2. C3A, when three calcium oxide is taken along with Al2O3, then formation of C3A, tricalcium silicate. C4AF, when we are taking four calcium oxide and one alumina and one Fe2O3 with tri and formation of C4AF, tetracalcium aluminate ferrate. These four constituents are very important in setting and hardening of cement. Again we are repeating: C2S, C3S, C3A and C4AF. Reactions involved in setting and hardening. Uh, Earlier we were discussing there are two type of reactions takes place when we are adding water in cement: hydrolysis and hydration. Hydrolysis means when the few new compounds are formed. Hydration means in a only simple addition of water in our constituents. First we are taking C3A. C3A means tricalcium oxide alumina. When reacts with 6 water, it forms thrice calcium oxide Al2O3 6H2O and release huge amount of energy, 880 kilojoule per kilogram. These all reactions, hydration and hydrolysis reactions, are exothermic in nature. They all are releasing huge amount of energy. This is a crystalline structure C3A.6H2O. It's a cubic structure. When we are taking 12H2O along with C3A, then formation of C3A12H2O, which is a hexagonal crystalline structure, and with 18H2O we formed, we are seeing another crystalline structure that is orthorhombic in nature. So these crystalline structures are formed with C3A with the different amount of water, that is 6H2O, 12H2O and 18H2O, respectively cubic, hexagonal and orthorhombic crystalline structures. With C4A, there is a formation of C3A, 6H2O and CFH2O along with whose amount of energy approximately 420 kilojoule per kilogram. Both structure are, this is gel and crystalline. Both structures are formed for C4AF. Next reaction is with C2S. It's very important reaction because there is a formation of topermanate gel which has very strong adhering property with the within a cement. It adheres stones and building materials, tiles, etc. The reaction with C2S is with water, hydration reaction and formation of topermanate gel. This C3S2 6H2O. C3 means thrice calcium oxide, S2 twice silica and 6H2O. It's a C3S2 6H2 topermanate gel with the again huge amount of energy 250 kilojoule per kilogram. It's exothermic reaction. There is a very important role of C2S in water and cement. These are some reactions which are important for setting and hardening of cement. So finally, setting and hardening of cement paste is due to formation of topermanite gel, which is we have already seen with the C2S. Crystalline structures of calcium hydroxide which are formed along with topermanate gel and hydrated tricalcium aluminates, as we have previously seen cubic, hexagonal and orthorhombic crystalline structures. These hydrated tricalcium aluminate, and for C3S there is a formation of again topermanate gel and huge amount of energy. So all are very showing exothermic nature. All are liberating huge amount of energy. The sequence of chemical reactions during setting and hardening: when cement is water added in cement, plastic mass form. Within a 1 day, hydration of C3 and C4AF takes place. After 7 days, gelatinous topermanate gel formation of C2S. After 28 days, all gel formation completed and the cement sets quickly. So hardening takes place. Hardening and setting both processes are takes place simultaneously. Hardening means stiffening of setting means stiffening of the original plastic mass, and hardening is the development of strength in cement. And very lastly, there is a reaction of C3A with the gypsum. As we previously discussed, gypsum is added in cement because to delay its setting time. C3A sets very quickly within a 1 day, so we are occupied C3A with the gypsum to form sulfur compound of C3A, which is insoluble in water. It sets very slowly, so it delays the setting time of cement. And if we adding alumina in high concentration, then quick setting of cement takes place. If we are adding gypsum, then setting time will be delay of cement. So it is the chemistry behind the setting and hardening of cement. As I am expecting all of you understand the phenomena of this chemistry, this setting and hardening. Main role of only four constituents. I am again repeating: C3, C2S, C3S, C3A, C4A. These four constituents reacts with water and gives different type of species which are responsible for setting and hardening. So very much thank you for listening. In another presentation we are discussing about the manufacturing of cement.